The actual dimensions of a pool are 20 by 15. So this is the word actual is in front of it. So we know, if I can, let me zoom out just a little bit. And we have a scenario where the actual pool, so you have to imagine this as being the actual pool, measures 20 feet by 15 feet. That's what's happening here. A scale model of the pool has a length of 30 inches. So, scale model, what do we use? What wording would we use if actual is involved? What's the other one? Diagram, right? Remember? Actual, I use diagram for the other one. That's my scale model. So I'll call this one diagram. It's very important to know which one is which. Otherwise, you're going to put the numbers in the wrong space. I know that the length of the diagram is 30 inches. This one is unknown to me at this point. Okay. So that's what's happening there. State the scale used. So for scale, I'm going to do that right here. The scale, I'm going to use these two. And remember, it has to be diagram, actual. That's how you want to state it. So we're going to go 30 inches. The 30 inches goes with 20 feet. And there are no decimals. Technically, you're fine. You could reduce that by dividing both of them. You can divide both of them by 10. It would be 3 to 2. If you prefer that, 3 inches to 2 feet, that's also okay. Okay. So that's A. B, you want the scale factor. We're going to take our diagram measurement and divide it by the actual. That's what's going to happen, okay? When scale factor, use that formula. So I'm just going to go sideways here. So we're going to go 20 feet. Nope, sorry. Get your act together, right? I'm doing this live, okay? I don't have the key in front of me right now. 30 and 20 feet. You're not done yet. You need to convert. So we know that 1 foot has 12 inches, and you want everything to cancel out. So you're basically doing a conversion. And so basically it's 30 times 1 is just 30. 12 times 20 is 240. Technically you're okay there. Technically you're good. I like to at least cancel out trailing zeros. You can do 1 to 1. So 1 at the very end, and at the very end, so it's 3 over 24. I think that is not too much work, and state it like that. When you do the decimal, don't go equals. Okay, don't go equals, you go comma, because technically 3 over 24, that is the answer as a fraction. Then you go 3 divided by 24. Now you state it as a decimal. And because it stops after 3, I use all 3 decimals. The reason I don't want you to go equals, because if you do have to round, then technically we're not equal exactly. Okay, so it's just a little technicality. Then I take whatever I have on the calculator and multiply that by 100, and I get 12.5%. So you have it in all 3 formats. If I don't ask you, stop right here. Stop right here if I don't ask you to do all 3 formats. Okay? Because otherwise you risk getting an error on rounding. So that's B. C. How much smaller or larger is the model? K is less than 1, comma, therefore it is smaller, no surprise. Okay. Since K is 12.5%, okay, the diagram is this much smaller. Okay, I'm not going to answer that yet. It's not 12.5 if that's what you're tempted to do there. We're going to go 100 minus 12.5. (87.5%). So it's 87.5% smaller. Okay. That's that. And what's the, if the pool floor needs to be covered with a liner, which comes in cans that cover 115 square feet, calculate the total cost if each can is $75. This takes you back to Reynolds, hopefully. So for D, I need the area of the floor to begin with. And we do have the dimensions. It's 20 times 15, right? So that's 300 square feet. And then I need to figure out how many cans. The liner could also be done in coats, okay? So you gotta watch out. Anything can be done in coats or in layers. So we go 300 square feet divided by how much one can covers, which is 115 square feet. That cancels out, so we go 300 divided by 115. That's 2.608 something. We're gonna go approximately, we're gonna say we need approximately 3 cans. We need to round up, no partial quantities. Now the cost. 3 cans times $75. It didn't talk about taxes. So when you're not sure, I tell my students to do this. This is the price before tax, right? And then you can say 225 times 1.12. You can say 252 after tax. So you're clear, you tell me you know what you're doing. You know which one is before, which one is after, and right? So it could be this one, or it could be this one. If it's not specified, you tell me you know what you're doing, okay? E. Let's cut this here. I like to section everything off. E. Determine the width of the model. I'm going to zoom back to the top, right? For a model, we don't know the width for the diagram here, so it's asking for it. So remember, you still use this one. Diagram, actual. Sorry, can't see that. I do know my scale factor, so I figured it out. It's 3/24 is equal to, the diagram is what I need to find, the width of the diagram of the model. I know the width of the actual. Okay, I know the width of the actual shape. So you cross multiply and divide. So it'll be 15 times 3 divided by 24. So 45 divided by 24, that's 1.875, and we are in feet. Chances are they would want it in inches, right? Because our diagram is in inches. No problem. Take it one step further. If it's asking to state it in inches, we're going to say that 1 foot has 12 inches. We're not violating the equal sign, because we're really multiplying by a fraction that's worth 1. Okay, 12 inches and 1 foot it's 1. So you cancel this out. Just multiply that by 12. So it's 22.5 inches. This is the best answer, I would say, in this scenario. Hopefully that helped.